data engineers that don't actually impact decision making are just running up cloud bills and moving bits around in the cloud without actually having any tangible impact. In this 2-hour course, we're going to be covering all of the things necessary to land an impact as a data professional, whether that be pushing back with stakeholders on low value requests, because the whole "can I get this data real quick" meme is a meme for a reason, and data engineers get burnt out from that over time. And so how do you push back there so that you can have more time to do robust data modeling that actually impacts decisions, not just for this quarter or next quarter, but for the next 4 or 5 quarters? And along with this stuff, we know that another layer in impact is communication and visualization. If you can display your data in a very compelling way, that is a very powerful way to impact decision-making processes. I'm excited for you to check out this course. This is the last of the courses in the 6-week free data engineering bootcamp, so I hope you enjoy it. The types of impact. You got measurable, hard to measure, and immeasurable. So if you think about measurable, it's you made a pipeline more efficient, congratulations, or you enabled an experiment to run that moved a metric. That's another easy way to have measurable impact. It's like you provided metrics that moved, that enabled an experiment to run, and that experiment caused these metrics to move. So you can claim some of that impact. Usually you need to claim that impact in collaboration with data scientists and product managers and stuff like that. You got to do that. Like, it's not like it's just yours, unless you're like a data unicorn and you're doing all of that. And I'm hoping that most of y'all will have more of those skills, kind of those experimentation skills as well, as you kind of learned a little bit in the bootcamp this time. Then you have hard to measure quality improvements. For example, if you don't have any data quality errors, like one of the things that's hard about measuring errors is it's like nothing going wrong is the measurement. The measurement is zero. The measurement is like no problems. And obviously you can measure those things. You can measure like how many errors are showing up and all that stuff. But like, and that's why it's hard to measure, because it's not necessarily that like you can't measure it. It's just that like, is it worth your time to actually measure it? Like, and in my experience, like most of the time in big tech, the answer to that question is no. Like they don't really keep track of like all of the quality errors that happen and how many are happening on each team over time. So that can, and because the thing is like the number of quality errors is not necessarily indicative of the quality, because you could also have more pipelines. It could be indicative of the number of pipelines, or it can be indicative of the amount of data quality checks that you're doing. So like more quality errors might actually mean higher quality because you're actually catching more bugs. So so that's where like that measurement is a very hard measurement to figure out. And that's a good example of something that matters. I mean, I'd say data quality matters, but it's also something that is tricky. Team enablement outcomes. That's another one. So I'm just going to give a quick example here about team enablement things. Something that I did at Airbnb or at Netflix that made my life a lot easier was I wrote this Groovy script thing that what it did was it made the amount of data that I had to ship to run my Spark job a lot less. It like cut it by like 60%. So then instead of taking 4 minutes to deploy, it took 1 minute to deploy. And I was able to get that code adopted across the team. And so we all saved some time. But it's hard to know how much time we actually saved. I mean, the only way we'd be able to do that is measure like how many times does each person on the team deploy, and then multiply that across the board. And obviously that's like probably some amount of time. Like, and I tried to get a kind of a back of the envelope calculation there, but it's not something that you have like the hard numbers for, and or would I ever like create a data pipeline about, right? I would never actually like spend the time to actually go and measure the impact of that improvement, because the value of measuring that is not worth it. Like, and it's the back of the envelope calculation is probably good enough to give you a good enough measurement, but like it's obviously not very accurate. So, but it's still impactful, and it's something that can definitely save a lot of headache for my team. But whether it's good or bad, or whether it's measurable or not, is like, and how accurate that measure is makes a big difference. And then obviously you have the third type, which is immeasurable impact. The big one here is changing intuitions, where if you present data to someone and then like if you present data to a leader and then it changes their intuition on how to make decisions, that can be one of the most impactful things you can do, because it makes it so that their default thinking is more correct. But that is very hard to measure. Like the only way you can measure that is if you had leadership take some sort of like bias test, and like they're not going to do that. And so So changing intuition is a big one. Team culture improvements, like if you're a good team player and you're very enjoyable to work with and all that stuff, that's another way to have a good impact. But like it's one of those things that is again, you could almost put this in the hard to measure because you could say like, okay, it's a measurement of retention. But then you have like team dynamics where it's like you might be the best team player ever, but like if there's another person on your team who's toxic or your boss is toxic, then like you might be adding to the culture, but then the other people on your team are removing from the culture. And it's like, is the fact that there's massive, attrition on your team, is that because of you, even if you are the person who is the person who's actually contributing a lot to the culture? So I put it in the immeasurable bucket there because team dynamics are very complicated. But that being said, that doesn't necessarily mean that you shouldn't be a good team player because it is something that matters. The last one here is called being a glue person. I found being a glue person to be a very important piece of this puzzle. What I mean by glue person is you're kind of the person that holds the team together, and you do a lot of the work that is not like as shiny or as sexy as like a lot of the other work. Like for example, one of the things I did to be a glue person at Netflix was I combined all of our team's code into one repo, and then I showed everyone how to use this like single repo, and that was a great way that I got everyone on the same page to for code sharing. That was cool. You do a lot. What I mean by glue person is you're kind of the person that holds the team together, and you do a lot of the work that is not like as shiny or as sexy as like a lot of the other work. Like for example, one of the things I did to be a glue person at Netflix was I combined all of our team's code into one repo, and then I showed everyone how to use this like single repo, and that was a great way that I got everyone on the same page to for code sharing. That was cool. I found that to be a really fun and great time. But like at the same time, it's like, what was that? What was the value there? The value there was mostly in the collaboration model, not necessarily in like, oh, I saved Netflix and number of dollars because now we are all using one code base. It's like very hard to measure. Very hard to measure like what the difference would be if we use 10 code bases and like how much time it would save. It's a very hard one. You know you could see that there's impact there, but you don't know what it is. Like you don't know exactly like how many dollars it is or how much money they're gonna save or how much time they're gonna save. You don't really know, but you know that there's impact there. And that's why being a glue person is super important because like if teams don't have glue people, they kind of fall apart, and then you just have a bunch of like really talented lone wolves who don't support each other, and that can be very terrible. And I've found that like the glue people are the people who get promoted to leadership. The glue people are the people who actually end up becoming managers and leaders because they are very good at banding people together. Whereas the lone wolf wolves, like sometimes they can be good too. They just like are more like I think they're more likely to become very technical ICs because they can be kind of a lone wolf in those cases and kind of build up that way. But even then, it's tricky for if you're working in that lone wolf mindset to get promoted beyond like senior engineer because of the fact that if you're at staff or higher up on the ladder, then you also need to lead and band people together and kind of sell people on a technical vision. So like it's very hard to work alone and become a leader. That's just kind of I hope that makes sense. Like the leader who is alone, that like sounds like an oxymoron, and it kind of is. And that's where like there's a lot of value in being a glue person. So I know I've just harped on that a little bit, but yeah, let's keep going. Okay, so how does your time as a data engineer translate into value? Well, there's a bunch of things here. I think the number one way that people, like, as a data engineer, like, if you if your grandma asks you, so what do? You like say, oh, I supply information to the business. I think that's like what most people would say is the kind of at a very fundamental level. That's what data engineers do. They supply insights. I think that is one of many things that they actually do, and there is going to be a lot more that they can also do as well. That, like, it's not just supplying insights. That, like, there's so many other tasks and ways that data engineers can have impact that is super important. Obviously, you have preventing bugs and maintaining data trust. Because if you have, if you're in an organization that has low quality data, then people are just going to use their intuition more, and their intuition is oftentimes a lot more likely to be wrong than right, and that makes the business, it's riskier for the business because a lot of data, then people are just going to use their intuition more. And their intuition is oftentimes a lot more likely to be wrong than right, and that makes the business it's riskier for the business because data is also wrong a lot of the time. Like, I mean, but like, it's wrong less of the time than your intuition is, and that's the whole point and why we use data and why we like data. Also, like, pipelines aren't free. You need pipelines that are efficient. You got to make you can save a lot of money if you make your pipelines efficient, and you either save a lot of money or you save a lot of time, because, like, if there's an error, if you have a very efficient pipeline that runs really quickly, then you can bounce back from a data quality error a lot faster. Like, for example, when I was working at Airbnb, one of the things I did was I added a staging step to the pricing and availability pipeline. And the old pipeline, if you wanted to backfill all of history, it took like 2 weeks. And with the staging step, it went from taking 2 weeks to taking 1 day. And so, and since it only took 1 day, like we were able to iterate way faster on the definitions of pricing and availability at Airbnb. And I also didn't feel so nervous about making mistakes because my pipeline was a lot more efficient. And so, like, I didn't have to, like, eat all of that backfill pain of 2 weeks of, like, babysitting my pipeline and hoping that it doesn't break by just making the pipeline more efficient. So that's another great way that you can have a lot of good impact. And I know that the next data engineer, he's going to be very happy with that, whoever took over my job at Airbnb. You also have enabling other engineers to work faster. And this can be in a couple different ways. One of them is through processes like code review. If you provide code review that helps people adopt best practices, more consistently, then that's a great way to work faster, because then it goes back to point 2 here of preventing bugs and maintaining data trust, right? Because if you use best practices, you're going to prevent bugs and maintain data trust. And if you prevent bugs, you're going to work faster because you don't have all the maintenance overhead that you would normally have from bad data quality. So that's going to be another great way to think about it. But there's all sorts of other ways. There's so many other ways that you can enable other engineers to work faster. I want to go over a couple more here. So I talked about that thing that made it so I could deploy my pipelines faster. Another thing I worked on at Facebook was I worked on this framework called Milky Way. And Milky Way allowed you to do all sorts of analytical patterns, essentially for free. So how it worked was you described the schema of your input table, and then you described the analytical pattern that you wanted to apply, whether that be, and almost all the analytical patterns that were available in Milky Way we have covered in this bootcamp. One of the analytical patterns was cumulation, like cumulative table design. Another one was growth accounting, or that kind of state change tracking. Another one was retention. kind of retention tracking. So that's one of the reasons why I wanted to cover all that stuff, because I found those analytical patterns to be heavily used at Facebook. But we built a framework that made it so you didn't have to write the SQL for that. You just had to describe the input schema, and then that was it. And then everything else would be done for you. And so that enabled data engineers to work a lot faster. It was like almost like the Chat GPT of 2017, where we were able to just be like, yep, apply this pattern with this schema. Take this schema and this pattern, and then you have your output data set. And so that was really fun. But that's another example where you can build frameworks and libraries that enable other engineers to work faster and better and with fewer errors. Like you can think of like another example here is like if you have engineers like for example Max Bjoichman, he worked at Airbnb, and he created Airflow, and he open sourced Airflow as a technology because he was like, the orchestration engines that we have right now, Oozie is terrible. I don't want to write my ETLs with XML. XML is terrible, and like it's painful, and like I want to be able to use loops and expressive stuff, and that's where you get a lot of that with Airflow, and that's another way that Max enabled people to be a lot more effective. And obviously that has been, you can have that be a very high level. If you think about like Max's impact there, it wasn't just at his own company, because Airflow is used like across the entire industry. And so if you want to really be at that next level, that's what you want to do, right? That's going to be the next one, right? If you are building things that make it so other engineers can work faster, that's going to be some of the most impactful and important work of your career. Last one here I think is important as well, which is around kind of like shifting culture and shifting decision-making processes. Because a lot of times companies, like if you're not in big tech and you're at other companies, like they might not be as data driven as big tech is. And so you want to also spend some time to not just like show like, hey, here's this high quality data, but also be like, yo, this data is like, you should be making decisions with this data. And if you're not, like you're flying blind and you're taking on unnecessary risk to the business that you don't need. So anyways, those are going to be like the 5 ways that you can essentially change your time for impact and time for value. And the more effective you are at each one of these buckets, the more you're going to be a better data engineer, and you're going to climb the ladder faster. Especially like if you can learn how to do every single one of these buckets effectively, then you're going to climb really quickly. But we're going to dive a little bit deeper into each one of these buckets because I think it's important. So when is an insight valuable? When you create a data set, right? Like for example, one of the things I did, right, in that experimentation week last week, and I did that red and blue experiment. One of the things that I learned from that experiment is that really it doesn't matter. It doesn't matter if it's red or blue. It really doesn't matter. And so if it doesn't matter, then that kind of goes into that third category of it fails to support or contradict intuitions. Because I predicted that the red button was going to do a little bit better, but like statistically speaking, they are exactly the same. So, but you can reinforce intuitions, contradict intuitions, or kind of like fail to reinforce or contradict intuitions. You can do all 3. And that can be a very important thing to remember, is that no result is a result. Like, especially when you're doing experiments, like if your experiment says there is no relationship between these 2 variables, and when like that, a lot of times like data scientists, they might consider that experiment like a failure, quote unquote failure, when that's not the case. Like you learn something. You learn that like these 2 things are not as correlated as you thought. That change doesn't matter that much. So like when you fail to reject the null hypothesis, like that is still a valuable thing. I think data engineers and data scientists, they get into this kind of rut when that happens though, because it comes back to that measurable versus immeasurable impact. Because when the null is rejected and there is a statistically significant result, then you can measure that result and you can say this many dollars, this many users, this many revenues, and that is good. But like when you don't reject the null, like the answer is like it doesn't matter. Like the change doesn't matter. Like, and it has no tangible impact. And so that is something to think about. Like another thing to remember here in data engineering is supplying insights in general is often overvalued. I think it can be a big part of our job, and it often is. Like it often is like a very, very big part of the data engineering job. But it's not everything. And a lot of times I think there's people out there in the world who think that it is everything, especially analytical partners. Analytical partners oftentimes will be like, hey, can you just pull this data real quick? Or, you know, that kind of meme and everything. And because it's not often that like supplying insights is just quick and easy. Okay, so here are some signs that your organization is overvaluing insights, because insights comes at the expense, the rate at which you create insights comes at a trade-off with the rate at which you create technical debt. And there's a balancing act there where if you want to just churn out pipelines every day and like not really insights that your organization is overvaluing insights, because insights comes at the expense the rate at which you create insights comes at a trade-off with the rate at which you create technical debt. And there's a balancing act there where if you want to just churn out pipelines every day and like not really care about quality and you just want to like have a bunch of data points, like you can do that quickly. I could create 50 terrible pipelines in a month, all right? And I could do that. And they might have like the data might be 80% right. And like it could give us directionality even. Like in the startup world, that might be a good play, because it's all about like getting answers as quickly as possible. But like you also want to remember that you want to create your pipelines and all your stuff in a way where once you build it, it can stick around for a long time. So if you want to come back to it, you can do that. So I'm going to talk about, I have a couple anecdotes on this slide as well for when an organization is overvaluing insights. Because analytical partners, when business is normal, analytical partners are very patient for the most part, and they are going to be like, okay, we can wait, we can get in with your long-term planning or your quarterly planning, we can get in on that. But that all kind of goes out the window when something crazy happens. So I'm going to give one example real quick. So when I worked at Facebook near the end of my time there, like Facebook saw its first dip in growth ever, and that was what was considered a crisis. And I essentially got pulled off all of my normal work I was doing, and I got put onto this like squad to troubleshoot this crisis as quickly as possible. And I learned a lot from that process. Initially, I felt very excited to be a part of that because I felt very important, where I was like, wow, I'm going to troubleshoot this very hard problem. I learned later on, as I've kind of done, and as I've had more of these crises in my career, that like I don't know, I don't necessarily think that it's like the best thing to do, because it's like you end up creating a lot of pipelines that might be low quality, or like you're not taking enough time on them because the analytical partners are not patient enough, and that can be a problem. And so one of the things that happened for me is like I know I churned out like so many different pipelines and measurements and stuff like that, and that's when I like kind of discovered different patterns. And that's where like in these crises, like if you're churning out a lot of pipelines, you should be able to notice like some higher level patterns. Like maybe that if you go back to like week 2 when we were talking about daily metrics or weekly metrics or monthly metrics or slowly changing dimensions or whatever, because most of the time when a crisis happens, what analytics is looking for is the ability to slice and dice and cut the data in every possible way that they can. And if you're doing your data engineering right, that usually means that you don't have to do anything, and that data is just available for them. And that's the long-term vision for data engineering, is that like you build the data infrastructure for them, and then they can answer whatever questions they want to answer, and you don't have to go and write ad hoc pipeline after ad hoc pipeline and burn yourself out. And so, anyways, for me, that's what happened. Like I was writing out like these ad hoc pipelines and trying to solve these problems, and like I got so burnt out. I felt so tired from working on this all the time. And one of the things that I realized was that I was overvaluing insights, and I was undervaluing tech debt and my own sanity and all sorts of other things, right? And so that's where it's important to think about things in a longer term vision. And that's another thing that can happen, right? Is in a crisis, like a lot of times it's more like I need this answer tomorrow, or I need this answer yesterday. And you don't have like, oh, I'm gonna deliver this to you in 2 weeks or 3 weeks, and then like it's gonna be like there's like a vision for what you're gonna be doing for the next couple days or the next week or two, and you get this kind of like I need to sprint the marathon sort of thing. I think we talked about that a little bit earlier last week, but and then the last one is ad hoc request hell, where you just have so many requests coming in, and you don't know which ones you need to actually fulfill, and which ones are not worth it, and which ones like should be passed or delegated or like even like removed from your task list. So a lot of that, like ad hoc requests, like hopefully that's something that you can work with your manager on, and you can get a good kind of way of like getting the stakeholder to do the upfront work. Where, because a lot of times I've noticed with ad hoc requests, if you make it so the stakeholder has to do more work themselves to give you a request, as opposed to them just being like, hey, can you pull this data? Because that's like easy. It's very easy. It's a very low effort for them to make a request. Like if you make it so that there's a little bit more of a barrier for them to make a request, where they have to fill out a doc or fill out a form or fill out something and like explain like why they need this data and all that stuff. That can be a great way for you to have a healthier relationship with your analytical stakeholders, because then you're not just like running around like a chicken with your head cut off, and you can actually plan ahead, and requests come in at a slower pace, because because they don't want to do it, because like they're only going to make a request when they really really need it in those cases, because it's work for them, and that's a good thing. It's one of those things that I kind of went back and forth on for a while, because a part of me feels like, well, we shouldn't slow down business communication. But this is something, especially in data engineering, that I think is kind of unique to this, because software engineers already have this. They already have a lot of this, like, okay, you want a new feature? Okay, put in a request. It's not like, oh, you want a new feature and we're just going to give you that data tomorrow. Like, they don't do that. They don't do that. And I think that that's one of the things that's changing in data engineering, is it's becoming more like software engineering, where you can kind of have more of that long-term planning. And so that's a key thing to remember here. These are the 4 things that can happen when it looks like your organization is overvaluing insights. That is the big thing to remember here, because we're talking about value here. We're talking about impact. So in this case, these are 4 signals that you can see that would be important to see that your company's probably has the bias a little bit wrong and is a little bit out of whack. There's another example I have actually for a crisis. So I worked at Netflix in 2019, and in 2019 that was when Disney Plus came out. And again, that was another example of where people were freaking out because they were like worried that like Disney Plus was gonna like take over and be really powerful and all this stuff, right? And again, we had some more like analytical, like really intense analytical sprints and stuff like that to like solve problems. And so you can have all sorts of different things that can happen in your company. And remember as well that like these crises will pass, and don't take them personally. Like, because I definitely felt like when I was working at Facebook, at least, that like I needed to solve Facebook's growth problem like by myself, or like I needed to do everything in my everything I could possibly do to solve this problem. And I don't know. I think that was like I definitely over indexed on like trying to solve this big problem when like I probably should have focused more on like myself and my health and my well being. But anyways, that's those are overvaluing insights indicators. So how do you push back? Pushing back and saying no is so important, because if you just say yes to everything as a data engineer, you're going to get burnt out. You're going to get roasted. You're not going to last very long here. I mean, a lot of people in data engineering don't last very long. Like many people, I think a lot of people drop out. I think it's like 80% of people drop out in data engineering after 5 years. So why? This is a big reason right here. So don't be afraid to say no. Don't be afraid to push back and tell your stakeholders that things can wait, and that like you're doing things as quickly as you can, and while maintaining quality, obviously, and push back. Say no. I love saying no. Say like that's like one of my favorite things in the world is to tell people no, that like it can't happen. And that can be a beautiful way to remember that like you're in this career for the long term. And like if you're getting all these requests that are happening on this like weird lurchy short-term basis, you're not going to stay in data engineering for the long term. You're not going to at all. Like, and so that's a big thing. Leverage your manager. Always, if your manager should be able to support you in these in saying no and getting the prioritization right. If they don't, find a new manager, like find someone else, quit the job, find a new job, because if they aren't able to like help you like maintain a good sanity and a good work-life balance, it's not the job for you. Obviously, another big thing here is around you want to communicate with your stakeholders about the fact that like if we go slower, we can go faster, because if we can build comprehensive and robust data models, then all of these one-off pipelines that they're asking for don't even need to exist. And they can just query the data, and it's just available to them. And that's where like if you have robust data models, like it's very powerful. It's insanely powerful. It saves your own sanity as a data engineer if you can get these robust data models, because then a lot of the analytical partners, they don't need one-off pipelines anymore. They can just go to the data and query it themselves. They might need help with like some of the querying, like they might not know how to do those like array functions or anything like that if you're doing like one big table. But maybe you can teach them, and then once they know, then you can you're good to go, and then they won't have to like bother you anymore, and you can again focus on more robust data models. And that stuff is very powerful. And the key takeaway from this slide is, remember, don't be afraid to say no. And that like the odds, like I think that a lot of data engineers have fear about that, because they fear like they're going to get fired, or they fear that that there's going to be a fight, or they fear that there's going to be like I don't know, some sort of pushback. And that's not what happens. Like I've generally found that like when you push back, that's when you get the most value. Like, and because then you actually saying no to something opens up the possibility of a conversation about priorities, and opens the possibility of a conversation around sustainable work environment. And so, because saying yes does nothing. Saying yes just gives them their value. And like, if you keep doing that, you're going to eventually burn yourself out. So those are some good antidotes to when insights are overvalued and you're kind of treated like a SQL monkey. These are going to be great kind of tips that I've used in my career to kind of maintain balance. Okay. Some of this stuff we talked about in week 3, but how do you maintain trust in data sets you produce, right? Quality checks. Obviously, you got to do right audit publish pattern, documentation, write a spec, just like what we were talking about before, because this trust, remember, trust is the impact here in this category. And then you have good engineering practices, use cumulative table when you can, minimize the amount of data that you're processing, and all that stuff. Clear expectations, make sure you have like an SLA so that people are aware of like what is, when this data will arrive, because that can be another way to minimize like communication overhead, because people are like, oh, is this data delayed? It's like, nope, it's only delayed if it's been over a day, or it's only delayed if it's been over 8 hours or whatever your SLA is. And so and then also document the gaps. I think that this is an important one to talk about real quick. So sometimes people might see your data set as like all powerful, and that like it's they put more trust into the data set than they probably should, and that is something that you don't want. I don't know if y'all ever saw the thing with Zillow. They've tried to like predict the housing market. They spent like hundreds of millions of dollars on the housing market in places, and they lost a ton of money. And so that is an example of where they had data sets that they believed in, but those data sets were not complete. They didn't cover all of the nuances of the housing market because that's a very complicated system to model. So that's going to be an example of a gap. And hopefully you can think about like things that might not be in the data set that could make the data more accurate. But that's going to be around clear expectations. I find data trust, it's interesting because this area I think has kind of gone back and forth, and it really depends on the organization whether this is overvalued or undervalued. I found at Airbnb it was like accurately valued, like it was like very fair. Facebook it was undervalued, where like Facebook they really did care about just like they overvalued insights and they kind of undervalued data trust and data quality. And Netflix was kind of more like Airbnb, where they kind of fairly valued this. But generally speaking, there's a lot of companies out there that like really just want you to give them a number, and they don't really care as much about like the sustainability, maintainability, or trust of that number, which is weird. I find that so weird. That's the case. Like why? Like, well, don't you want to care about like whether or not you can actually trust this number? So, anyways, quality is an undervalued way of delivering impact as a data engineer. So remember that as you're kind of going throughout your career. So what about efficiencies? Efficiencies and quality are related. Efficiency
Efficiencies is almost like a subset of quality. But we talked about a couple of these things. Proper data modeling is a great way, right? That was weeks 1 and 2. If you data model correctly, you're going to save a lot of time and pain and frustration. Improving on-call. If you're in the combined track, like we did a lot of stuff last week on data pipeline maintenance, and so that's going to be a great place to see what you can do there. Reducing data volumes. This could be like through sampling or compression techniques, like leveraging Parquet format. We're also going to be covering a lot of Parquet stuff in the Spark week this week. It should be fun. Picking the right tool for the job. So I think this is an important one to talk about real quick. I have another anecdote for y'all. So when I was working at Facebook, there was a big push to get off of Hive because Apache Hive was like the main big data technology we use because Hive is slow and expensive and terrible. And they were like, okay, we need to move to Presto. And I was like, okay. And one of the things about Presto is if you have more than 1 terabyte of data, Presto is going to run out of memory because Presto had like a 1 terabyte memory limit. And I was like, well, my pipelines are like 10 terabytes, so I guess I can't use Presto. And that was like kind of a crazy thing for a little while there where I was like, what do I even do? And I was like, I want to make my pipelines more efficient, but I can't use Presto, and Presto is what Facebook wants everyone to move to. And so what I did was I waited a bit, and then I talked with the data platform team, and I was like, yo, can we get Spark? Can we get Spark on my team? Because I know if I get Spark, I'll be able to freaking process my data way more efficiently if we move to Spark. And then I got access to some Spark machines, started migrating things, saw a massive improvement. But you see, like, one of the things about this is like picking the right tool for the job. Like, I did try Presto for a while. I actually did try to use Presto for wherever I could, and I was like, this is dumb. Like, this doesn't work. Like, and like Hive, literally the older technology was the better choice in those cases. And like, I was surprised by that because I was like, I thought Hive was old and slow and terrible, but like, it was old and slow and terrible, but it actually ran. So like that was made it better. So you never know what tool might be the right one. Like I definitely noticed this as well when moving stuff from Hive to Spark is that like Spark could actually in some cases be more prone to running out of memory because it leverages a lot more like RAM compute, and because of that, Spark actually can fail more often than Hive. So in some cases, it's not a clear trade-off. It's not just like, oh, it's so much more efficient, but it could fail more often as well. So you want to be careful when you're like migrating and upgrading and being very aware of the trade-offs that you're making. Okay, so another thing to think about here is like simplifying model and reducing capabilities a little bit. So sometimes your data science partners, like they want you to have every column under the sun. Like a lot of times it's like quote unquote like just in case, and then like you put it in there and then you regret because like then you look like after 6 months they've never queried it and you're like, okay, why did we bring this column with us? Like why if they've never actually used it? And it's like, oh, are they gonna we put this column in for the one chance that they query it one time in 5 years? I don't know if that's worth it. I think that that's probably not worth it. And so that's where obviously there's you have to be aware of like the impact of these things. Like for example, there was an I have a kind of a trait. I have an example of like the other side, right? Of like when that line of thinking actually doesn't work. And like that was like when I worked at Netflix and I worked in security. I worked a lot on like security audit logs and like auditing like if a security incident happened and in those cases like those logs are not queried that much. They're only queried in the case of a security incident for the most part. And those didn't happen very often. So in those cases, like, yeah, it makes sense to have that data on hand. Or like another example is like maybe you need to hold on to data because of legal reasons or privacy reasons or things like that. Or and if you need that, like then that makes sense. Like if you're like bound by law, then that's fine. I think generally speaking, the way I look at it is like if it's like something related to security, legal, or lawyers or privacy, then there's going to be probably more of a flexible nature of this number 5 bullet point. But if you're in pretty much anything else, like then you really want to think about whether or not to bring in the column, because if so many times data scientists have told me like just in case, and then they never query it, and so in those cases, it would probably be better to just not have the column, and there would be no downstream or any sort of impact from that.
Congrats on getting to the end of the day 1 lecture. If you're taking this class for credit, make sure to switch to the other tab so that you get credit for it.
What I want y'all to do is, there is a repo. You'll see in here, there's a data 6 data impact training repo that I want y'all to be looking in here. There's a data impact training repo that I want y'all to be looking at. So essentially what we're going to do is we're going to be doing a text file today. And this is not going to be too bad. So you can either pick events or devices. It doesn't matter. We're going to go with events. And then what we want to do here, this is just so that we can create an aggregated data set. And so in Tableau, you can do joins like in the workbook. Generally speaking, I don't consider this best practice, but I like this for this case in particular. So all you want to do is you want to drag devices.csv onto there, and then it will try to guess. And it's going to say, oh, we're going to join on device ID. And it's like, that's right. So we're good to go. That's essentially it for kind of how we're going to be building out some of our dashboarding stuff today. And then I don't know if y'all have ever
Data engineers